All right, looks like it's time to get started. Glad everybody joined me before the after party. I guess I'm the only thing separating you all from that. So it should be fairly quick. I'll jump right into it. I'm Richard Williamson with Silicon Valley Data Science, and I'm going to be talking about Hadoop and Spark for the SAS developer. So just a bit about my background. Worked with Walmart stores for about 15 years. There did a lot of data science and big data. Actually started on the management science team. The only tool we used there to start with was SAS. So I thought that it would be very fitting to talk about that and bring back some of my roots. So that was in the first part of that career. It was a bit tough coming directly out of a computer science program and then being somewhat confined to the SAS language. I often saw that it was a very good fit for the specific domain of doing data set type manipulations. Until later I found SQL to be a very good place to do a lot of that. So moving forward to about 2009, I had the privilege of our marketing customers bringing a project to us to build out a marketing sandbox where they wanted a analytics platform where they could do large analysis at the customer level versus the store level. So as part of that, they were just asking for SAS and Teradata as the technologies to support it. But I was able to convince them to take 10% of that budget and build out a Hadoop cluster. So we built a 20-node POC cluster that compared to an 8-node SAS grid environment and a 40-plus node Teradata environment. And soon into that POC, we realized that we could do a lot of queries within Hive on Hadoop that we could not do in the other technologies that they had asked for originally. And then fast forward to a couple of years ago, I realized that I'd been more in the data engineering realm than I wanted to be, so I came to Silicon Valley Data Science, where we help our clients build out analytic solutions on top of platforms like Hadoop or Cassandra. So as most of you probably know, if you came to the talk, SAS is the largest market shareholder in advanced analytics, with over 36% market share in 2012, according to Wikipedia. And Spark is definitely the newcomer to the area. But the nice thing is, even though it only started in 2009, it's quickly become the most committed Apache project out there. So what I really liked about Spark is it actually reminded me of what I used to do in SAS. There's a basic programming model, consists of the SAS data step and SAS procedures inside of SAS. And within SAS, you use data sets to move data between processing steps. Spark similarly uses Scala as its native programming language. And also has Java and Python and now some R implementations to use the Spark framework. And it uses RDDs to move data between the processing steps. So here's the, so let's dive into some code. Hopefully you can see that well in the back. Unfortunately, I didn't have a SAS license, so I just went and grabbed some code out on the internet. And on the left, on the left, you can just see a basic data step where we're loading some data in through the data lines command in SAS and creating the data set called old. And then on the right, we're doing the same process inside Spark. Just starting out with SQL context and a case class, which basically takes the two variables, state and account total, and loads those into a list structure. And on the right side, I actually put them out of sort order because one of the things I was showing was to sort it, which I couldn't necessarily do on the left side. That's the only difference in the data. So the next piece kind of jumps into the basic model behind SAS is that you'll have procedures to do the common tasks. So the first thing's a proc sort, where we're just sorting the data back into itself, into the old data set, and sorting it by state. On the right side, you see the same operations happening with first, the thing that we do to get data loaded into Spark is the parallelize statement, and that basically parallelizes the data across the Spark cluster in this case into a RDD called old RDD. And then the next step just converts that to a data frame, so we have a schema with that RDD. And then the third statement there just does the sort, similar to the proc sort was on the left. The next step is your typical data step inside SAS, where we're basically using a by statement to come up with the changes in state. Since it's already sorted, then we can start a counter that's used to count those things. Not the most common way you do counts, but you would use this to do more complex operations in here other than just a count. On the right, we do the same thing with the aggregate by key inside Spark. You'll notice it's a little more concise using lambdas there basically. And then the bottom, we're taking basically doing a frequency, which also does the same count, the procedural style within SAS. And that's where I introduced the group by on the right, which is very similar to the frequency. So you've seen a little bit of the data sets that we worked with on SAS. So I just wanted to define a little bit further here. The Spark data frame really now is replacing the RDD for most data set processing implementations. It's basically an RDD with schema. So it was actually called schema RDD up until the most recent version, if you look at the footnote there. But a Spark data frame is basically a distributed collection of data organized by name columns. And the nice thing is it's distributed, so you get to use lots of machines to process on it. Whereas the SAS data set is generally just a non-distributed form, and it has a file that's associated with that data set that's stored on disk. And one comment I like to make here is that with the data frame, you basically get the power of HDFS to use the processing out. So, for example, the Hadoop cluster that built at Walmart ended up growing to 300 nodes and had about 4,000 disks on it. So you basically get that degree of parallelism with the reads of every disk gets to read through there, whereas with the SAS data set, it's not distributed. Okay, so how does the Spark data frame differ from the SAS data set? Again, it's just built from the ground up to be distributed and can be processed in parallel by multiple machines, as I just noted. And then the SAS data set is, it's also a logical entity, so it's not necessarily the same serialization format that lives on disk. You may, for example, store the raw data in Hadoop as Parquet format, and then you serialize it in as the RDD. Whereas the SAS data set, you generally can go have a one-to-one mapping from the disk versus the logical view. So the nice thing about Spark is that it has SQL context, just like SAS Proc SQL, if anybody's familiar with that. So the first reaction to Spark SQL for me, hey, this looks like Proc SQL, because it was basically, if you look at the snippet of Proc SQL right below, you can basically treat data sets within SAS as tables, and then perform SQL on them inside this Proc SQL step. And then here's the same version of that done inside Spark SQL. So the only main difference is you actually represent the new table outside versus inside the SQL context. Okay, so moving along, often what people really want to use SAS for is analytics versus just data processing. However, what often happens, I've found, is that you end up doing a lot of ETL just inside SAS. So for the analytics side, there's packages called Spark MLlib, which the current algorithms there include classification, regression, clustering, collaborative filtering, and dimension reduction. On the SAS side, it's actually a separate package called SAS Stats that has many of those functionalities inside. And then there's also, on the more workflow side, there's an enterprise miner that does some of those. So just wanted to give you a taste of some of the quick data processing we do to do the regression inside of Spark. This is actually coming from an example that I worked up off of Meetup data for the Strata conference earlier in the year. And that's out on our GitHub site in case anybody wants to go pull this code. Just Silicon Valley Data Science GitHub. But within here, the first step is basically you'll see another case class like we saw earlier on, where we define the schema for a data set by time. And then we do some processing on that and register it as a table. And then what I really like about the environment is you can switch back and forth from the Scala processing side here to the SQL context. So I created this, the data set Meetup 5 was just a normal data set. And then I switched back into Meetup 6 as a SQL data set that I can then perform SQL on. And that's basically the point I wanted to show there. And then the next step, if we want to go perform regression on this, is to actually map this into a feature vector. And then the middle line there is actually goes and runs the regression on the training data. And then once we have the regression model built, we can go score a new data set with that regression model. And that's the next block. And then at the bottom, we're printing out basically the results of that regression. And then the other exciting thing with the Spark environment is that we can not just do the batch processing things that we would typically do in a SAS environment, but we can do stream processing on the data coming in. So here's just an example of taking a 10-second micro batch of data coming in. It's actually connecting to Kafka, which is commonly used in the Spark or Hadoop environment to stream data in. And that's also a distributed message platform, so we basically get the distributed part all the way through here. And then we can also then use the things like the SQL context inside of here to actually just run SQL inside of our data processing pipeline for the streaming side, which is very handy. So just wanted to kind of give you a snippet of that. I didn't actually put the full streaming regression part in there, but you could go through and do a streaming regression on that data coming through. So key takeaways I hope you've learned. Spark really is a place where we can now do our analytics in a completely distributed fashion. So if you have large data, like I used to have at Walmart, on the order of 200 billion rows, we can take that data and now push it into a platform that's distributed from the ground up. And if you want to take control over your code, you now have the functionality with whether it be Scala, Java, or Python, or R, to not just be stuck in like a macro language for more specific implementations on your data. And then if, as most of us are trying to do now, get all or most of our data being streamed into a Hadoop environment, Spark is the perfect place where we can start processing that data. And last but not least, if you prefer the open source licensing model, then definitely you should try out Spark. All right, and at this point I'll take questions. Unfortunately, I have an ear infection, so I will do my best to hear your questions, but I may ask you to repeat them. Yes.
So from the quality of statistics between these two alternatives, do you have any confidence? At the end of the day, it's about the statistics.
Yes.
And, I've been around a few blocks, and SAS is always like the gold standard for quality.
Yep.
So I was wondering if you have any thoughts, comments.
Yeah, I would definitely say if you're looking for like really advanced features of the procedures, definitely still look at SAS. For any of your basic statistics and things, those are getting very solid inside the Spark environment and are continually being added to. Any other questions?
So what use cases would you recommend a SAS developer to move them to Spark?
So it really depends. I kind of bias myself towards using it for most use cases now. So especially if you have any non-batch workloads where you want to do any type of stream processing, those use cases are definitely going to fit in the Spark environment better. Also, the very large data processing pieces, if you're doing, anywhere in the billions of row range, a Spark platform backed by Hadoop is definitely the way to go. Yep, go ahead. Oh, sure.
In terms of size, the problem is data set size. SAS is making a big deal about their Hadoop integration. I was wondering.
Yeah, to be honest, I'm a bit dated with that. We actually started some of those conversations when we had the SAS grid working with the Hadoop environment. We actually couldn't get some of the integrations going at that time because our Hadoop environment had Kerberos security around it and we couldn't pull the data in. But definitely, I would recommend if you have that type of platform, push as much of the ETL workload back into the Hadoop side of things and then do the statistics in the SAS side, which is where its strength's going to be. Does that make sense? Answer your question?
We're in a position now where we're kind of doing bake-off.
Ah.
We'll be doing it. I mean, what the ingredients of a bake-off might look like.
Yeah. If you want to chat afterwards, I'd definitely love to get more details on that. So. Yeah, in the back.
Follow up on that. Did you say you had challenges integrating SAS with Kerberos?
Yes, we were actually trying to use Fuse as the direct link at the time, and there was no support for that, so we ended up not having a good way to move data back and forth. It's been a couple of years since I've looked at that, so I can't comment on the current state of that. Yes. With Spark streaming, it is defined as a microbatch. So you set a window like a couple of seconds up to a minute or whatever your batch wants to look like. There's other stream processing pipelines like Storm that's event-based, where you can actually do event-based processing versus the time window. It really depends on, do you have to have sub-second response times for those events, or can they be batched up into micro batches? Any other questions here? Good question. Definitely, you'll want to not just try to learn Spark, but you'll want to learn Scala. So Scala is a very, what's the best way to say it? It's a very concise language, I would say. So just learning the structure of the language and things. So doing like a 3-day training class or something on Scala, unless you want to work like in the PySpark or RSpark environment. But definitely make sure the base language is strong that you're going to work with first and then move into the Spark side. Yeah, Scala is the first level citizen, so everything goes there first, and then you may have to wait a few months or so before it gets ported to the other platforms. So.
Are there speed trade-offs if you use R?
I haven't actually benchmarked too much of the speed side of things. It's more of a functionality thing, and I would say it's probably more important which language you're comfortable working in, and would not worry as much about the performance from that side. Did you have another question? Or are you good? Okay. Any other questions? Well, I'll be up here if you'd like to come up afterwards. I have part of my team here as well. Thank you.